Hey, hi, good morning, everyone. 1 minute to share my screen. Okay, we'll quickly revise what we were doing in the last class and then we will move on to the new topic. Okay. In the last class, I believe that we mainly discussed two main things. One is R square and the other one is your VIF, right? So in R square, what it was, let me go there first. Okay, cool. I think the R square discussion started with this point that when we think of error, right? Let's say, accuracy in terms of classification. In classification, the target variable is categorical. In a regression, right, the target variable is continuous. That's what the difference is between, classification and regression. So let me just maybe write that down as well. Insert new slide and then. So what happens is that when it comes to machine learning, machine learning can broadly be classified into two parts. Okay, one is supervised. Another one is unsupervised. Okay, supervised machine learning technique, unsupervised machine learning technique. Supervised machine learning technique means that it has target. It has a target variable. Unsupervised machine learning technique means that it does not have target variable. Okay, when we have target variable, the target variable can be of two types mainly. One is your continuous, another one is your categorical. If the target variable is, if your target variable is continuous, and let's say your target variable can be categorical. Okay, when the target variable is continuous, what kind of a machine learning technique it is?
Regression. Linear regression.
Regression, right? Linear regression is a type of regression, but let's say whenever we try to predict a continuous variable, that will be called regression, and linear regression is a type of regression technique. Okay, and this point will be a very important point in our next machine learning technique when we will be discussing logistic regression, right? As I was telling, regression means that the target variable will be continuous, right? And linear regression is a type of regression technique. Okay, we will also be discussing logistic regression, right? By the name of it, logistic regression, what should be our target variable?
Categorical.
Continuous, right? No?
Regression continuous.
When I say linear regression, it is a regression. So target variable will be continuous. Logistic regression. So regression means target variable will be continuous, right? But we will see in logistic regression that our target variable will be actually categorical. Okay, so that is a very important point, right? That why logistic regression is called a regression, although it is a classification machine learning technique. Okay, so when we will be discussing logistic regression, that will be the point from where I will be starting the discussion. Okay, that the name is logistic regression, but we are not going to do regression. We are going to do classification. Okay, then why we are calling it regression is something. If you will understand why we are calling it regression, although it is a classification, you will understand half of the logistic regression. Okay, now whenever target variable is continuous, it is regression. When the target variable is categorical, it is called classification.
Here, what is logical regression? I didn't get.
Logistic regression. Logistic. We will be discussing it. It's a type of machine learning technique that we will be discussing after linear regression. Okay. We have not discussed it yet. So when the target variable is continuous, right, then we cannot do a exact prediction, right? Let's say, for example, if someone's height is 168.9, right? Will I be able to predict exactly 168.9? No, I might predict 168. I might predict 169 also. That will be, if someone will predict 169, I will call it a very accurate prediction. If someone will predict 168, that is also good, right? So saying that if it is not exactly equal to 168.9, then if it is directly exactly same, then it is right. Otherwise, it is wrong. That's not how we can measure performance of a regression technique. Okay, although in case of classification where we have to predict 0 and 1, right? So for 0, if I'm predicting 0, it is right. For 0, if I'm predicting 1, it is wrong. For 1, if I'm predicting 0, it is wrong. If for 1, if I'm predicting 1, then it is right. Right? So in case of classification, it is very easy. If the actual value is 0, I'm supposed to predict 0. 1 will be considered wrong. Similarly, if the actual value is 1, I am supposed to predict 1 and 0 will be considered wrong. But regressions are a little different. In a regression, even though if the value is not exactly the same, even then it can be, right? It can still be considered correct. Like even this will be considered like equally good. Yes. Right? So in case of regression, we try to measure the error. We don't try to measure accuracy. We don't see that whether the value is exactly matching or not. What we try to measure is, we try to measure RMSE. Okay. So we are trying to measure error. How much is the error? Because we assume that from accuracy perspective, it will be very, very low, right? The values cannot match exactly in most of the cases. So all we have to do is by how much we are missing it, right? That's why in regression, we focus on RMSE. In case of classification, okay, we focus on accuracy. Because there, the accuracy is very easy to calculate. If the value, actual value is 0 and the prediction is also 0, then it is accurate. If the actual value is 0, your prediction is 1, that is inaccurate. Okay. So we started our discussion from here. And then we were discussing that in case of classification, like accuracy, in general, we assume from here that the range of accuracy will be, what will be the range of accuracy? Theoretically,
0 to 100%.
right? 0% to 100%, right? Either all of your prediction is wrong, that will be 0%, or let's say if your all the prediction is right, that is 100%. So this is the range of accuracy from 0% to 100%. What is the range of error?
The error is measured above the average, the minimum.
Right. Like, but theoretically, it can vary from 0 to
0 to 100.
0 to infinity.
Okay.
Right? Let's say if I am trying to predict the price of the car, I can be off by 5,000, 10,000, 50,000, right? Not just by 100 rupees, 200 rupees, right? So the error can be very big as well. But because it is a positive value, root mean square error, the minimum value will obviously be 0. Okay, this is theoretical. But practically, I was telling you that later, what happens is, practically in case of, classification, right? In classification, let's say I have certain values of some percentage of 0, some percentage of 1. And then we talk about minimum accuracy. Okay. So I have some percentage of 0, some percentage of 1, and we talk about minimum. So let's say in my data set, 0 and 1, you can assume it as, let's say, maybe male or female. I'm trying to predict, right? Whether someone is male or someone is female. Or it can be whether someone is a good customer or someone is a defaulter on the loan, right? So let's say, or a very popular example that we take is 0 is, let's say, if you don't have, if you have cancer, and 1 is, let's say, we are trying to predict whether someone will have cancer or not cancer. Okay. Now, if in my data set, 25% customer are having cancer and 75% remaining are not having cancer. Okay. So what is my minimum accuracy, which is possible?
Having cancer or not having cancer?
75%.
It will be 75%. It will come when I will call everyone as 1, right? If I have 1,000 patients in my data set, if 25% are having cancer, that is 250. If 75% are not having cancer, that is 750. Right? If I will call everyone having not cancer, let's say these I am also calling not cancer. This is what my prediction is. For this, I am also calling not cancer. So out of these 250, how many of the predictions are correct? All these 250 are having cancer, and I'm calling prediction as not cancer. So my 0 predictions are
0.
correct, right? Similarly, all these 750 are not having cancer, and I'm calling not having cancer. So how many are correct?
100%.
100%.
100%.
That is 750, right? So my accuracy will be, accuracy is how many correct predictions I have done. Total is 750 plus 0 divided by total number of predictions that I have done. That is 1,000. 75%. Point being is, here the minimum accuracy will be 75%, because even if I will call everyone as not having cancer, then my accuracy is 75%. Right? Similarly, if in one data set this is 35%, right, and this is 65%, what will be my minimum accuracy?
65.
5%.
65%, right? Because if I will classify all the patient as not having cancer, even then I will be correct 65% time, right? So your model accuracy should be at least greater than 65%. Okay. Similarly, if my number of cancer patients are 60% and number of not cancer patients are 40% in my data set, my minimum accuracy will be
40.
60.
60% this time, right? Because this time what I will do, I will
Cancer.
call all the patients as having
Cancer.
cancer, right? So this is how we get to know at least, okay, like theoretically, obviously, zero accuracy is possible, but in general, we consider this as a benchmark that your model should perform at least better than this. Okay. Similarly, when it comes to regression,
So it's like how do you know that it is 60%?
how this will be 60%?
Yeah. Are we looking for not classic cases or classic cases?
No, that does not matter. No, I'm saying that let's say if you have thousand cancer patients, sorry, 1,000 patients, out of which 60% has cancer. So it means that 600 patients has cancer. 40% do not have cancer. It means 400 do not have cancer, right? Now I want to make a model, and Sumit, to answer your question, right? If I'm trying to make a model, anything that you want to predict, let's say whether someone is having cancer or not, or whether someone is not having a cancer or not, right? It's one and the same thing. It does not matter. Okay. If you are trying to predict whether someone is having cancer or not, then cancer assume it to be 1, not cancer assume to be 0. If I'm trying to predict whether someone is not having cancer or not, then not cancer is 1, cancer is 0. Okay. But it does not matter, uh, because if I'm predicting someone is having cancer, right, as 1, uh, and in some cases saying that, okay, this person is not having cancer, right, it will automatically go into the second bucket, right? Let's say you are a doctor, right, who is specialized in detecting cancer. So when the patients will come to you, right, what are the two classes in which you divide the patient? A few patients, right, you like this patient has cancer, this patient does not have cancer, right? Do you have a choice to choose that, okay, I will just only tell who has cancer, or I will just only tell who does not have cancer, right? You would have to tell both, right? The same thing is there. You cannot say that, okay, whether I'm trying to predict cancer or I'm trying to predict not having cancer, because they're just complementary of each other. Okay, so if 60% has cancer, that is 600. So what I will do is I will say that all of the patients have cancer. So this 600 all has cancer. This 400 all has cancer, right? So this all of my predictions will be wrong. All of my predictions will be right. So my accuracy will be total right prediction divided by total number of predictions. That is 60%. Okay.
Why we are considering the cancer, like 60% cancer, non-cancer 40%. We can
Mhm.
predict everyone having non-cancer.
Right. We can predict everyone will have non-cancer, but then your prediction will be only 40% accurate, right?
Yeah, actually, that was the point I was trying to ask.
Mm-hmm.
The minimum accuracy, what are we calculating for? Like for having cancer or not having cancer? So that answer is changing, right? Like 40% is my accuracy for the model having not cancer.
Okay. Let's try to discuss it from a little different perspective. Let's say you are a person. Let's say there are two people. One is Puneet, one is Sumit. Okay, Puneet is trying to create a model to who all customers I should give loan. Okay, Sumit is trying to make a model to who all customer I should not give a loan. Okay, let's say these are the two scenarios that we have. Let me make a new sheet. Okay, Puneet, to whom should we give loan? And let's say Sumit, not give loan. Okay. Now, what are the different scenarios that I have? Let's say there are different customers, customer 1, customer 2, customer 3, customer 4, customer 5. Okay. And let's assume that I already know that this is a bad customer. This is a good customer. This is a bad customer. This is a bad customer. And this is a good customer. Okay. Now, Puneet's model is trying to predict whom should I give the loan, right? So should I give this person loan? The answer is no. So 0. Should I give this person loan? The answer is yes. Should I give this person loan? The answer is no. Should I give this person a loan? Answer is no. Should I give this person a loan? Answer is yes. Okay. On the other hand, Sumit's model, what Sumit's model is trying to do? Sumit's model is trying to predict to whom I should not give the loan. Should I not be giving loan to this person? Yes, I should not be giving. Should I not be giving this loan to this person? No, I should be giving. So that's why 0. Should I be giving loan? Should not I be giving loan to this person? Yes, I should not be giving. I should not be giving, and 0. Right? This is the only difference which will happen by the way, let's say Puneet is approaching this approach versus Sumit is approaching this approach. Okay. The only difference is what you are calling it as 0, what you are calling it as 1. Right? But if when it comes to, let's say now there is another person, Vinay. Vinay is the bank manager. Right? Vinay is the bank manager. Whose model Vinay should use? Puneet or Sumit?
Anyone.
Anyone, right? It does not matter because Puneet will tell me also the same thing. Sumit will also tell me the same thing. Sumit, is it clear now?
Yeah, it's
Right? Because
One doubt is there. So
Uh-huh.
why we have this minimum accuracy based on the one which have more number of patients?
Okay. Let me
Like-
let me give you a data. Okay. Okay. I am telling you that in a room, let's say there are 90% female and 10% male. Okay. Now, so let's say total 100 people are there. I will be randomly calling one person at a time. Okay. I will be randomly calling one person at a time. And you need to tell me whether that person is male or that person is female. Okay. Whether that person is male or female. You cannot touch that person. You cannot see that person. You just don't know, right, who is coming. But for every right prediction that you will make, I will give you 100 rupees. Okay. So I'm going to call, let's say, the person 1. What will be your prediction? Whether it is male or female?
Female.
Female only, right? If I'll call person 2, what will be
Yeah.
your prediction?
Female.
Female, right? So let's say like this, if I will call
Yeah.
all the 100 people in the room, I'm assuming for all of them, you will be just calling female, right?
Yeah.
And why you are doing that?
Because I'll get money for this. So I have to
Yes.
make a
Right. So you need to make the maximum right prediction, right? And you know that the best way to make prediction in this scenario is to call everyone as female, right? Because if I will do that, my 90% prediction will be right. Yes or no?
Yes, yes.
Right. Now, similarly, let's just flip the scenario and we say that, I have,
If I know that only 90% are female, so after 90 people, I'll start saying it male, no?
no, but do you know, like maybe the first 10 people that I called was male.
Okay, okay.
right? In that case, you will end up making an incorrect prediction 20 times.
Yeah. Okay, okay, yes.
Let's say this scenario. In this scenario, 70% are male, 30% are female. And I'm calling one by one everyone. You don't know anything about that person. So if I'll call that person, what will be your prediction this time?
Maybe.
Male, right? Everywhere I will just simply, if I don't know anything, I'll just simply call everyone male. And what will be my accuracy in that case? 70%,
70%.
right? So I will definitely choosing the majority class and I will tag it to everyone and I will get at least that much accuracy. In this case, 70% accuracy. In this case, 90% accuracy,
Yeah.
right? The same thing I was doing here as well. Whatever is the majority class, I'll start calling everyone by the same thing,
Like here we have the idea about the database, how the
right?
information is.
Mhm. We will always have the data, like the data with us, no? Without data, there will anyway cannot be any machine learning, right? So we'll always have the data. Clear? Right? So we started with this point that the minimum accuracies in general, like theoretically, it is 0% to 100%, but practically, we can find the accuracy. In case of regression also, right? Although the error can vary from 0 to infinity, but I can think of the maximum error. Okay, I can think of a maximum error. What will be the maximum error? What will be the maximum error? The maximum error will come, right, when my prediction is same as average. We believe that this should be the basic model. If your model is performing poor than this, then there is no point of having that model altogether. Okay, if your model is giving more error than this model, right, then there is no point using that model. Okay, so your model should perform at least better than this. When we say at least better than this, means that the error should be at least less than what the average model is giving me. Okay, from there comes the concept of R square. Okay, when we say that how good our model is performing, we don't measure that betterment from 0. We don't say that, okay, like let me go here. Yeah, we don't say that if model was not there, I would have been predicting 0. No, we say that if model was not there, I would have been predicting this much. And because of model and the error was this much. If there was no model, then this would have been the error, not this, not this. Okay. If there was no model, this would be the error. So this is the maximum error which is possible. Not this. This is not the maximum error. Okay. Theoretically, yes, this is the maximum error, but practically no. Why will I predict 0 when I can predict average? Right. So this is practically the maximum error which is possible. Okay. Out of this much, this was the maximum error which was possible. I was able to cover this much. This is how much I was supposed to predict more to get the 0 error. Out of this maximum error, I was able to cover this much. So R square is nothing. R square tells me that of the total which you were supposed to cover, like B plus C, of the total that you were supposed to cover, how much you was able to cover actually. Okay. So the range of R square will be definitely between 0 and 1. right? Because as you can see, right, it will always be less than 1 and greater than 0. Right? So R square is nothing, but we are trying to compare our model with respect to the average model. Okay, got it? Right? Because for regression, the minimum value is not 0. The minimum value is average value. Okay, so this is what we had discussed. Then after this, we were discussing that what will happen if I will have a duplicate variable in the data set. Okay, if we will have a duplicate variable in the data set, then will my accuracy increase or decrease?
Remain same.
Remains same. Remains same.
It will remain same, right? Always remember it like this, that if by adding a duplicate variable, my accuracy will increase, hypothetically, right? If it is increasing, then I will not stop at once. I will duplicate the variable 100 times, add it to my model, and make my model 100% accurate, right? So, which is illogical, right? It's more or less like telling the same information again. Okay, it's more of a like I'm asking you to predict the height of someone, given that you know the gender of that person, that okay, that person is female. Now try to predict the height of that person, right? You will make some prediction, let's say maybe 5 feet. If I will again tell you, no, that person is female, right? You are not going to change your prediction based on that. Just because I'm repeating the same information, right? You are not going to change your answer, right? You will not be able to predict better just because I repeated it twice, thrice, or 5 times. Okay, the same thing happens here. The model is smart. The model knows that you're giving me the same information again. Obviously, that is not going to add any incremental value. Okay, at the same time, obviously, I will not make my model worse either. Okay, so the accuracy will remain same, but the problem is about the coefficients. Okay, the coefficients become unreliable when we have related variables. Okay, that's what we were discussing. Then the impact of accuracy, there is no change in the accuracy. But the impact of coefficient, yes, the coefficients become unreliable. It means that I'm not sure whether the coefficient is correct or not, whether the coefficient's actual value is 80 or is it 159. I will not know. Okay, so to solve that problem, we said that what we will be doing is, okay, to solve that problem, we said what we will be doing is, we will be doing VIF. Okay, we will be doing VIF. And what is VIF? VIF is variance inflation factor. Okay, the fund of VIF is very same. VIF try to check whether there are related variables in the data set or not. Okay, whether there are related variables in the data set or not. Okay, so let me write it down. So we have VIF. VIF is nothing but variance inflation factor. Variance inflation factor. Okay. What is the problem that we were trying to solve? The problem that we had in hand was the problem that we had in hand was that whenever we have related variables, okay, duplication was just an extreme example, right? Where the variable was exactly same as the other variable, right? But in general, obviously that happens very rarely, but there are many times there are variables which are related to each other. Weight of the car and length of the car, right, can be related. bigger the, lengthier the car is, more will be the weight of the car. Okay. So whenever the variables are related to each other, there is no impact on model accuracy. But coefficients of the variable become inaccurate. But the coefficient of the variable become inaccurate. What is the meaning of this? Let's say if you are trying to make a model and you are planning to use that model only for prediction, you don't care how that model is built, how each variable is contributing to that model. You don't care. All I care is what is your prediction. Right? If you're only interested in prediction, then there is no need to do VIF, right? Because the problem that we are trying to solve using VIF, this problem is not having any impact on the model accuracy, right? But let's say if you are interested in the coefficients of the variables, by coefficients of the variables, I mean that if I will make a 1 unit increase in the variable, let's say, for example, here, if I will increase the horsepower by 1 unit, my price will change by $159. Similarly, here I'm saying that if my horsepower increases by 1 unit, the price will change by all $80. So which two out of these is correct? If I will increase my horsepower by 1 unit, whether the price will be changing by $159 or will it be changed by $80?
159.
159, right? If I'm interested in that kind of questions, then it's important to do VIF, right? Because using VIF, I am not making much of an impact on the accuracy. Actually, accuracy will go down a little bit because of this, right? But how VIF is going to help me? VIF is going to help me in making my coefficients more accurate. Okay, so if your aim is only the model accuracy, then no need to do VIF, but you are actually interested in knowing how each variable is impacting my target variable, right? You want to kind of understand the model in that way, then I need to do VIF. Okay, so this is the problem that we have. What is the solution? Okay. Solution for this is VIF, right? So what VIF does is we will dump all variables in VIF function. That is the first step. Second step is sort variables by their VIF value. Third is remove the top variable. Right? So we will dump all the variables into VIF function. VIF will give us a score, okay, for each variable. Then we will sort our variables by VIF value. And if the top variable by VIF value, right, is having the VIF value greater than 2.5, then I will drop that variable. Okay, and I will rerun the I will rerun the VIF function. On remaining variables. Last part, repeat the process till you have no variable where VIF value is greater than 2.5. Till we have no variable okay. So the main point here is, right, which a lot of people do it wrong, that we need to remove the variables one by one. Okay, we need to remove the variables one by one, not all the variables at once, right? Like the example that we have over here, right? If I will just remove the variables where the VIF value is greater than 2.5, then I will end up removing horsepower and horsepower 2 as well, both the variables. Okay, which will be wrong. Horsepower is an important variable for us. Okay, so what I will do is I will sort this data and I will remove only one variable out of this. Let's say I will remove horsepower. Then I will rerun the VIF function again. And this time you will see that the VIF value will go down drastically. Okay, is it clear?
Yes.
Any
This
question?
is nothing. This is nothing but you are trying to find the correlation.
Right. Yes.
It's the broader way of calculating across all variables.
Right. So correlation in general is calculated with one variable, right? Between variable 1 and variable 2. I cannot calculate correlation between variable 1 and variable 2 and 3, right?
Yes.
So actually how VIF work is, whenever we have more than one variable, we don't look at correlation, we look at simply linear regression. So what VIF try to do is it takes each variable and try to predict that variable by using rest of the variables. If I'm being able to predict this variable by rest of the variables, using rest of the variables, then this variable is not needed, because the rest of the variables together are being able to predict this variable. So this variable is not adding any information.
Puneet, consider we have like 20 variables, like 20
Right, right,
and we apply the VIF.
right.
Out of which, consider top 5 which is greater than 2.5. So we remove multiple, means at a time we remove the 5 variables at a time, and then
No,
we
no, no,
again we have
no.
are one by one.
One by one. So we will, even if you have, let's say 20 variable and there are 10 variables whose value is more than 2.5, even then I will just remove one, the top variable. Okay. Then for
It
the
is like,
remaining 19 variable, again, I will run the loop.
it will take a lot of time, right? Means if
Yes.
you remove, like consider if I have 100, 500
Hmm.
variables at a time, then if we apply VIF,
Hmm.
then it will take a lot of time.
Right. You're right, but that's the right way of doing it. Right. We do make approximations, right? Sometimes we just, like, when you're dealing with the data, a lot many times we already know which variables are important, which variables are not important, or let's say these variable will anyway come out, correlated with other variables, right? So you can take a call. Let's say if you have 500 variables, maybe you can remove 10, 20 variables at a time, right? But that's what you are doing because you want to save time, not because that's the right way of doing it.
Okay.
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 Right. So we do a lot of things to save time. A lot many time we just drop a variable which we feel is not important, which is not a right way of doing it, right? Ideally, you should not remove a variable just because you feel it is not important, right? But we do that, still do it. Why we do it? Because we want to reduce our data size. Okay. So ideally, yes, this is how we should do it. And the good part is, in general, VIF does not take a lot of time to run. And don't think that you will be sitting and then running it let's say 500 times manually. You will just write a for loop, right? You can do that. You can write a for loop in which I will be adding all the variables, sorting all the variables by VIF value, remove the top variable if the value is more than 2.5, then again run the loop and keep on learning the loop till there is no variable where the value is greater than 2.5, right? Sound doable?
Yes, yes.
Right? So we need not to do it manually. We can just simply write a for loop and that will be enough.
Puneet,
Puneet,
we have
Mhm.
weight and length of the car as two correlating variables. And in the order, we got weight as the first one and length as the second one, and both
Right.
has greater than 2.5 same value, suppose.
Right.
So in that, we are gonna remove the weight variable which is coming on the top, and we are keeping the length variable. But
Right.
that weight makes a good I mean, it plays a good role in keeping that variable in our model. Then we might be losing that important variable, right?
Right, right. So all of these things, right? Like in machine learning, the best part is that everything is for direction purpose, right? So nothing is a fixed rule. So ideally, yes, we should do it this way. But if you want, no, I don't want to remove the top variable because that looks very important to me, or that's the variable that I want to finally keep in my model. So you can remove the second highest also. You can remove the third highest also, right? And even if, let's say, in the last, this variable is still having VF value more than 2.5, and you still want to keep it in your model, even then you can do that, right? So everything is from direction perspective. A lot many calls we take based on the scenario to scenario basis. Okay. So you are right. I need not to remove the top variable. If you feel that that variable is important to you, don't remove it.
Okay.
Puneet, will there be a case if I remove the VIF of top one, the rest of the variables increases?
Generally, that never happens, right? Always
Oh.
VF value I've seen that it decreases. Okay, when
Okay.
you will remove the top variable, then it will decrease. See, again, so how VIF is working, as I was telling you, in VIF, this is how it works. Let me just tell you. Let's say if I have 5 variables, how VIF work is, I will keep variable 1 as my target and I will try to predict variable 1 using variable 2, variable 3, variable 4, and variable 5. Then I will keep variable 2 as my target and I will try to predict it using variable 1, 1, 3, 4, and 5. I will keep variable 3 as my target and I will try to predict variable 2. These will become my input variables, right? I will repeat it 5 times. And how much accurately I'm being able to predict a variable, that will tell me, let's say here, variable 1, I'm being able to predict with a very high accuracy. So VIF value will become very high. Why? Because it is telling me that using variable 2, variable 3, variable 4, and variable 5, I am capturing the same information that variable 1 is giving me. Because these variables together are being able to predict variable 1. So VIF value will be very high. Hypothetically, in this case, using variable 1, variable 3, variable 4, variable 5, I'm not being able to predict variable 2. Okay, if I'm not being able to predict variable 2, it means that whatever variable 2 is bringing, that information cannot be captured using these variables, and that's why the VIF value will be low. Okay, now let's say by doing all of that, we ended up removing variable 1. Now for the next iteration, how many variables I have?
4.
4, right? Variable 2, variable 3, variable 4, and variable 5. Now variable 2, I will try to predict using variable 3, variable 4, variable 5. V3, I will try to predict using variable 2, variable 4, variable 5. V4, I will try to predict using variable 2, variable 3, variable 5. And V5, I will try to predict using variable 2, variable 3, variable 4, right? Now tell me, let's just take any example. Let's take example of variable 2, right? In the first iteration, I was trying to predict variable 2 using variable 1, variable 3, variable 4, variable 5. In the second case, I'm trying to predict it using variable 3, variable 4, variable 5. So these three variables that I have was present here also. Now tell me, don't think it from a VIF perspective, think from a modeling perspective. If I will remove, if this is what my model 1 is, if this is what my model 1 is, if this is what my model 2 is, if I'm talking about the accuracy of model 1 and model 2, will model 1 accuracy will be greater than model 2, or model 1 accuracy will be less than model 2, or model 1 accuracy will be same as model 2? What do you think?
Second one.
Second one? Okay. Why?
Same.
Model.
Okay, let me write it on the top. In model 1, we were using variable 1, variable 2, variable 3. Sorry, my bad. For model 1, we were using variable 1, variable 3, variable 4, variable 5. And for model 2, we were using variable 3, variable 4, variable 5.
M1
In
greater
which
than M1, M2, right?
M1 greater than M2?
Yeah, because V1 was the top variable, right? So we removed it.
Mm-hmm.
Guessing the model, so the values will decrease after that.
Right. So always think it from this perspective. If I will tell you more about something, okay, either your accuracy will increase or it will remain same, right? Let's say if, like we have discussed this, I think many times before as well. If I'm trying to predict height of someone and I tell you the gender, if you don't know anything about that person versus you know the gender of that person, will your accuracy improve or it will decrease?
Increase.
Your accuracy will increase if you will add gender. If I will tell you the height of the parents, will your accuracy increase or decrease?
Increase.
Increase.
Increase. If I will tell you in which school he has studied, will your accuracy increase or decrease?
No impact.
Same.
No impact, right? No impact. So it will be same as what it was earlier. So either by adding more variables, either the accuracy will increase or it will remain same. It will not go down. Okay. Whatever, like from a model perspective, if I'll give him 10 variable, whatever variables are relevant, the model will listen to them. And whatever the variables are irrelevant, the model will not listen to them. Okay. So by adding a new variable, either the model accuracy will go up or it will remain same depending upon how much relevant that variable is. Okay. So when I am moving from model 2 to model 1, I am adding one variable. So now either this is possible when I'm adding one more variable that the accuracy will increase for model 1, or it might remain same. But it cannot happen that in this case I had more accuracy as compared to this, right? So model 2 accuracy will either be less or it will be the same. And that's why the VIF value for model 2 will either be the same or it will be less. So VIF, whenever we move from one iteration to another iteration, will either go down or it will remain same, because VIF is telling you how much accurately you are being able to predict this variable using the rest of the variables. And because with each iteration, I'm removing the number of variables, so either the VIF will remain same or it will go down. Clear to everyone? Any question?
Puneet, can you please repeat the correlation part that you mentioned? Like,
Which one? Correlation?
like you mentioned about how like compare We can only
Yeah.
compare one variable with other and not.
Right. So I was saying that whenever we want to compare one variable with the another, I can use correlation, because correlation can only be defined between two variables. Okay, variable 1 and variable 2, or variable 1 versus variable 3 versus variable 1 versus variable 5. But when I want to understand what is the relationship between one variable and a lot of other variables, right? Actually, that study in itself is called machine learning only. Whenever we try to predict what is the relationship between one variable and the rest of the other variables, right? That is nothing but machine learning. So I was saying that if you want to understand relationship between two variables, maybe I can use correlation. But if I want to study relationship between one variable and a rest of other variables, I would have to use machine learning. Okay.
Okay.
So what will be its usage, like say it's for feature selection and which feature will be using, right?
Yes, right. Especially like feature selection we do because of multiple reasons. One reason is, let's say, to reduce the runtime. If I have 500 variables versus 50 variables, the runtime will be less in case of 50 variables as compared to 500 variables, right? So there are multiple reasons because of which we do feature selection, right? Here in this case, we are doing feature selection, you are right. But the idea behind doing feature selection is, the main idea behind doing a feature selection is that I want to increase the accuracy of my coefficients. Okay, I want my coefficients to be more accurate. That's why I'm doing VIF. So yes, it is a feature selection technique, but the main purpose is to increase the accuracy of coefficients. Any other question, anyone? Okay. Moving on to the next part, right? So VIF thing we have done.
Puneet, so mentioned that greater than 2.5 if VIF is there, so we have to remove. So from a from a theoretical perspective, what does it mean? Does it mean that if it is greater than 2.5, the variables are related?
Yes. That this variable is being explained by the rest of the variables, so we don't need this variable.
Okay, got it.
But in general, VIF will decrease or it will remain same, right? Most cases, it will not go.
Yes, right. Okay, with each iteration, VIF will either decrease or it will remain same. It will not go up. Let me share a new code with you. Okay, I've shared one code with you. Can you guys please upload it and give me 2 minutes? I will be back. Okay, please upload it in Colab and then we will discuss it.
Where will be? कौन है लगा? No, I have a class going.
Have you guys uploaded it?
Yes.
Yes.
Okay, nice. Okay, let me first read the file. Okay, first time takes a little time because it's connecting to the server. Now we can just select the file that we have uploaded.
Puneet, if you are uploading the file using this collab code, so will that remain for next run also? Like tomorrow, if I want this
No,
after
no,
again.
you would have to again upload it. So the first part, we were uploading the file to the server. Let's say, for example, I'll go to this folder right here on the side. You will be able to see this file that we have uploaded. You can directly upload it from here also. Like if you click on this, you can upload it, but
yes,
better to do it through code here. Then from that server, we are creating a variable, right? The file which exists on the server, we are creating a variable. Same thing again, the the libraries that we imported last time, same libraries we are importing. It's just that the only difference between the last code and this code is that this time we have like there's new 8 variables. Last time we had only 2 variables, right? Car ID, 3 actually, car ID, horsepower and price of the car. This time we have in total 8. So we have drive wheel, car length, car width, car height, car weight, horsepower, and price. And then we will try to see that whether by adding more variables, whether our accuracy is increasing or not. Okay. We use this shape function. Like, see, most of the codes you need not to remember. Okay. But like the basic ones, like for example, this is something that you should know, right? Like the dataset.info, dataset.shape. If I want to look at the top 5 rows, how can I look at the top 5 rows, right? At least this much we should not be Googling. Okay. If I want to filter rows, add a new column, remove a column, select a few columns, right? All those things we should be able to do without doing much of a Google. But rest of the things you need not to remember a single thing. Okay, very basic ones you can remember. Okay, so here, for example, it is telling me that I have 205 rows and I have 8 columns. Okay, let's see if we have any missing values or not. No, we don't have any missing value. Everywhere 205 rows are values are present. Now, when I look at the top 5 rows, I see that the first column is car ID, which is nothing but a random number assigned to each car.
With year 205's rows.
Yes, 205 is number of rows.
But we only got 5, right? Okay, you're taking only 5. Okay.
Yeah, I'm taking only 5. We have drive wheel. I will discuss that. We have car length. Car length is nothing but the length of the car. Car width, again, nothing but width of the car. Car height. Curb weight is nothing but weight of the car itself. Okay. Horsepower is nothing but how big your engine is. And finally, the price we are trying to predict. Okay. Now, let's discuss drive wheel once. Drive wheel is nothing but I have three values here. RWD. RW is nothing but rear wheel drive. FWD, nothing but forward wheel drive. And 4WD, this is nothing but four-wheel drive. Okay. What is the meaning of this? The meaning of this is that rear wheel drive means, okay, let me maybe Google it and it might give you a better picture. Rear wheel drive versus front wheel drive. Okay. Which one will be better? Yeah, I think this one will be a better image. So if you look at the front wheel drive, right, this is the front of the car where the engine sits, right? In the bonnet, we have the engine. From engine, if you are driving giving power to the front wheels, that is called front wheel drive. Okay, this is where your engine is. You are powering the front wheel and this is called front wheel drive. Similarly, this is where your engine is in the front under the bonnet. And then you're powering the back wheels. Okay, that is called rear wheel drive. Okay, now why these two mechanisms are there? Like these both mechanism has its own advantage and disadvantage. Okay, when we have front wheel drive, in general, the transmission is very smooth because you are not taking the power and sending it to the back. Taking the power, sending it to the back is a complex mechanism. It sounds very easy, but taking the power from the engine and sending it to the back wheels, it is little complex. Right? So because it is complex, it requires more parts. The car become more expensive also. Right? Then why we are not having all the cars as front wheel drive? Why we are having even rear wheel drive? Because front wheel drive also have a few disadvantage. One disadvantage is that in general, like how do you steer your car? Using the front wheel or the back wheel? How do we steer our car? Using the front wheels, right? In front wheel drive, we are steering the car using the front wheel. We are powering the front wheel also. So rear wheels are not doing anything. The front wheel are doing two things. They are steering the car as well, and they are powering the car as well, right? Which makes the power efficiency of the engine a little less. Okay, the steering quality is also not very good. In rear wheel drive, because the steering happens from the front wheel and the power is happening through rear wheels, it is in general more stable car. Okay, the ride quality will be much better in rear wheel drive as compared to front wheel drive. So front wheel drive, although the system is simple, less expensive, but the ride quality is not that great. In rear wheel drive, although the system is more complex, okay, it is more expensive, but the ride quality is better. So out of these two, which one you are expecting it to be more expensive?
Rear wheel.
Rear wheel drive, right? Rear wheel drive will be more expensive as compared to front wheel drive. Okay, so that's why it is an important variable. There is something called four-wheel drive as well. What will happen in four-wheel drive? Any guess?
All four will have transmission power.
Right, all four will have transmission power. Like Thar is again a good example. Why four-wheel drive? In four-wheel drive, we power all the four wheels for off-roading perspective. Okay, let's say if your front two tires get stuck somewhere, so your back two tires should be able to pull the car. Similarly, if the back two tires get stuck somewhere, the front two tires should be able to pull the car. In general, four-wheel drive is only used when you are planning to do off-roading. Okay, otherwise there is no, in cities there is no use of it. Okay, that's why most of the military vehicles are four-wheel drive. Okay, and that's why four-wheel drive are actually not very expensive as compared to rear-wheel drive. Why? Because rear-wheel drives are in general more expensive, more luxury cars. On the other hand, four-wheel drive are in general more off-roading cars like Jeep, Thar, and all of these. In these cases, the car is not that expensive because the rest of the things that we put on those wheels is not very expensive. Okay, so just
Uh,
like why I'm telling you all of this? I'm telling you all of this is because we should know about our data set when you are doing machine learning. Okay, so that you will have some theory in your mind that okay, this is what might happen if I will use this variable.
Puneet, in general, like what percentage of cars are forward rear versus four-wheel drive?
I believe 70 to 80% of the car are front wheel drive. Like maximum cars are front wheel drive only. Very few, maybe 5%, 6% cars are rear wheel drive. Like very expensive cars, like need to be at least more than 40, 50 lakhs in India to be rear wheel drive. And the rest of the like 15, 20%, not even 20%, like 10, 15% cars are four-wheel drive. And most of those, that percentage is coming through Thar only, I believe. Like the big car that I know, which is four-wheel drive, is Thar, the popular car that I know, right? And rest of the military vehicles, yes. Most of the military vehicles, most of like all of the military vehicles will always be four-wheel drive.
Got it. So we cannot remove any of these variables also because they contribute, like even if it's 5%, still
It
there
is
is so many.
right, exactly. Yes. Right. And it's not about 5% also, it's also about how much this variable is contributing also. It is not a less important variable, it is a very important variable. Okay. Sometimes, when the variable is present for a very few number of rows, we can remove it. But in this case, it is a very important variable because the cost of the car varies a lot by which wheel we are powering. Okay.
Yeah, got it.
Now, the next thing that I'm gonna do is like this one is a categorical variable, makes sense. The rest of it is a continuous variable, so makes sense, right? Car ID, integer, drive wheel, object. Object is nothing but categorical variable. The rest of it is either integer or float. So makes sense. It's just that car ID is a categorical variable. It should not be continuous, right? Although again, I will not be using car ID, but I have this habit that making sure all the variables are in the right format before we can proceed. So I'm going to change car ID to object. Okay. Car ID is not a continuous variable. It is a categorical variable. Although I will not be using it, but I still will be converting it to categorical. Okay. In the next one, what we are doing is we are looking at the distribution. How many cars are front wheel drive? How many cars are rear wheel drive? And how many cars are four wheel drive? Right? Just out of curiosity, again, all of this we are doing just to understand the data better. Because if you understand the data better, as I was telling you, in machine learning, there are no rules. Everything is a direction. So why everything is a direction? So that you can take your own calls depending upon your data understanding. Which variable is important, which variable is not important, right? Which variables might be correlated and all of that. You should be able to take those calls, and you can only do that if you will understand the data, right? Let's say in the next case, I'm looking at the average price. And first I looked at what is the percentage of rows which are coming from each wheel drive. And in the second one, I'm trying to see what is the average price. So if you look at it, the four-wheel drive has an average price of 9,200, right? Rear wheel drive, on the other hand, has a price of around 20,000. So more than twice. Okay, more than twice. That's why rear wheel drives are in general not so common. Most of the cars will be front wheel drive. And then you will see that the four wheel drive is 12,000 or 11,000 actually, right? Less than rear wheel drive. Why so? Because four wheel drive cars are in general off-roading cars. For off-roading cars, you will not be putting very expensive, things in the car, right? Because you know that for off-roading perspective, no one wants to buy a very expensive car. You will not be taking a Lamborghini and going on, your Leh Ladakh trip. Doesn't make any sense. Okay, so in general, for four-wheel drive, although the system is very complex, but the rest of the things that we put on the car, those are not very expensive. Okay, so that's why this is 1200. So now we know, we have some idea how the price is changing. In the next part, what I'm doing is I'm separating out all the numeric variables, right? So I'm separating all the numeric variables. Why? Because in the next part, I'm going to create a correlation metric. Correlation can only be calculated between continuous variables. That's why I wanted to remove categorical variable. I wanted to use only continuous variable. This correlation metric will tell me what is the relationship between each variable. For example, car width and car length. See how these two are correlated. It means that lengthier the car is, higher are the chances it will be wide as well. Right? 0.84 is a very high correlation. Okay. So that's one thing. Is there any other variable? Right? Weight of the car and length of the car. See, longer the car is, heavier it's gonna be. Okay. Weight of the car and width of the car is also correlated. Right? Is there any other variable? Right? These are the main ones. So car width, car height, and car weight seems to be, not car height. Actually, car height is not correlated with the length and width. See? So car height does not matter much, but weight, width, and length, these three variables seems to be correlated with each other a lot.
Can you explain like how it's correlated?
Because the correlation value is very high. Like car length and car width, 0.84. Right? What is the maximum correlation value?
1.
What is the minimum correlation value?
0.
0.
-1. -1, right? If a variable is perfectly related to the other variable, then it is 1. If it is perfectly negatively correlated, then it is -1.
-1.
Right? So because the highest value is 1, this value is 0.84. It is a very high value. So car length and car width are correlated with each other. Car length and car weight is also correlated with each other. See, 0.88, very high value. Anything above 0.75 is considered very high. Okay, I will wait till here. Ask me if you have any question.
So here car height is not having certain correlation, I mean, better correlations with the remaining data, right? So can we drop?
Right. No, actually it is a good thing. If your variable is not correlated with the other variables, then it is a good thing. Why? The first thing is always and always remember, my input variables are also called, what is the other name for input variables?
Independent.
Independent
Features.
variables, right? Yeah, feature is also there. Independent variables. Independent means that they are not related with each other, right? This is what independent means, right? So one good thing that you should look into every variable is that it should not be dependent on others. So actually from that perspective, car height is a good variable. It is not correlated with other variables, right? On the other hand, car length and car width as of now are not so good variables because they are related with each other. So we would have to remove a few variables out of it. Okay.
Okay.
So
Puneet, can you just explain, like I'm not getting how we are correlating these values?
So this is a matrix, right? So let's say, for example, pick any two variable, like tell me any two variables from this list.
Car height and length.
Car height and car length, right? Like for example, so you will tell me, take any two variable, I can tell you the correlation value. Car height, car length, 0.49. Right? Similarly, if someone will ask me car weight and horsepower, it is 0.75. right? So any two variable you will give me, I can tell you what is the correlation value between those two variables. This is what this table is giving me. Between car weight and car weight, correlation value of 1. Right? That's why the diagonal is 1. Okay. So correlation metric gives you relationship between correlation value between any two variable. And car length versus, let's say, car height. Car length versus car height will be same as car height versus car length. Car height versus this is also 0.49. This is also 0.49. Okay. So variable 1 versus variable 2 or variable 2 versus variable 1 will give me the same value for correlation. Is it clear, Likita?
Yeah, yes.
Yeah, Puneet, what is the range when we say that both the variables are highly correlated or not very correlated?
So in general, from around 0.6 or 0.65 to 0.75, we consider it as mildly correlated. It is correlated, but the relationship is not very strong. But from 0.75 onwards, right, it is considered a very high correlation, strong correlation. Okay, so anything above 0.75, you can consider it as strong correlation.
If it is 0 between two variables, then we say they are not very high correlated. Like
Yes, they're
much
actually not
correlated.
correlated at all.
Not correlated at all.
Yeah.
If it is negative again from which value we say that they both are highly negatively correlated?
Anything less than minus 0.75.
Okay.
Right? Less than minus 0.75 means minus 0.75 to minus 1.
That means they're inversely correlated. If it is coming as minus, that means they're
Yes.
inversely correlated.
Yes, they are related, but they are inversely related.
Inversely
It means that if one variable will go up, other variable will go down.
Okay.
Right? Here, the car length and car width are positively correlated. It means that if the car length will increase, the width will also increase. Okay. Now, the next thing, the same thing is there, is just that we have created a colorful chart out of it, so it becomes easy to read. Wherever it is dark blue, we know that there the correlation value will be high. Wherever it is of light yellow or greenish color, there the correlation value is low. So it becomes easy to read the numbers. The numbers are exactly same as what we had in the last chart. Okay, again, basic things you guys can remember. Like for example, this CORR, right, is the function for correlation. Something that we can remember. Okay, basic one-line things I would suggest you should know. It makes the coding a little faster, but other complex thing you need not to worry about. Let's say, for example, if I need to select a set of variables, right? I should not be doing a Google for this. This much I should know. Like if I want to select a set of variables, how can I do that? Right? So I believe whatever you have learned is NumPy, Pandas, and Matplotlib, this much you should know on your own. The rest of the things you need not to remember. I believe this much you have also learned in NumPys, right? Pandas.
So this line means we are selecting all the rows of these columns, right?
Yes, right. Okay, so like last time, and this is again a very standard thing that we will be doing it. We will be separating the the input variable and the target variable. Very standard thing. Like 3-4 codes you will see in every machine learning code. Separating out input variable and target variable. The next part will be doing dummy variable creation. You guys remember what was dummy variable creation?
Yeah, we added a constant variable.
Right? No. We didn't add a constant. What was dummy variable creation?
Creating categorical variable into numerical.
Right. Changing categorical variables to continuous variable. I cannot put a gender flag, let's say, for example, in my in my machine learning, male female. My model does not understand what male female means. Okay, I need to give values in numeric format. So, for example, my model does not understand what rear wheel drive, forward wheel drive, or four wheel drive means. I need to convert it to numeric. So I
one
will,
hot encoding.
yeah, one hot encoding. Very nice, right? That's the one. So what I'm doing is I'm using this function called get dummies. Okay, and here I'm writing this condition drop first equal to true. Any guess what this condition is doing?
So it will remove the.
It creates indexes of it.
No,
Old
It will
one
remove the
data.
one column.
no. It will, sorry?
It will remove the one column.
Why it will remove one column?
Because I think it's not necessary because zero.
We found duplicates.
Not duplicates.
To arrive at a
Actually,
decision of n columns, I think n minus one columns are sufficient. Maybe
very nice. Very nice. Sunil. Yes. Okay. So actually that's correct. So like if I have a variable in which I have three unique values, like forward wheel drive, rear wheel drive, and four wheel drive. How many variables are needed to explain this variable? Two variables. Okay. If you guys remember, this is what we had discussed, right? If I have gender column which has value male and female, okay, then I need one variable to explain this. You guys remember this or not? This conversation?
Yes, n minus 1.
N minus 1,
Yes.
right? So here drop first equal to true means that if I had not, let's say, if I will remove this condition, it will give me three variables, right? But three variables are unnecessary. We know that. Okay. So what we are doing is by default, I'm saying that, okay, remove the first one. So I will have only the last two. Okay. So if there will be 5 categories, it will give me four columns. If there are 10 categories, it will give me 9 columns. If there are 15 categories, it will give me 14 columns.
Like in the case if you have male or female, one column should be fine.
Yes.
So we need not need the other one.
Right.
Yeah, both of them zero means the four-wheel drive will automatically be one, right?
Four-wheel drive will automatically be one. Yes.
And then,
Right. Yes.
Like, how to know like which value to remove?
No, it is just removing the first one. It is just sorting it. If you sort it, you will see that it will be four-wheel drive, front-wheel drive, and then rear-wheel drive. So it is just removing the first one. Right? It does not matter which one you remove and which one you keep. So we are just randomly removing the first one.
Okay.
Why we are writing data type as int?
Why we are writing data type as int? Yeah, actually, if you will not write it, I'll show you. What will happen? It will give you, instead of 0 and 1, it will give you true and false. Okay. I don't want true false. I want 0 1 for my modeling.
Okay.
That's why. Okay. In the next part, what we are doing is, can anyone explain me what we are doing here? I've commented it as well. What we are doing?
So in the X1, okay, we are removing that all categorical columns
Right.
and keeping it intact.
And
again, we are
Hmm.
keeping it intact. I mean, we are just removing all the categorical
Right.
columns.
Right.
Okay. In the second statement, pd.concat, okay, we are concatenating car dummies column to X.
Very nice, right? So what we are doing is we are removing that categorical variable that we had, right? We had this categorical variables in this drive wheel. So I'm removing that variable and I'm adding the dummy variable that I had created. These two variables I had created. Okay. Yeah. Now what happened is because I had already removed it, it is giving me an error. So I'll just run it again. Okay. So I'm dropping drive wheel column and I'm adding these dummy variables that I have created. And that's why if you in the next code, you will see that car wheel drive column has gone. That variable does not exist now. I have car width, car height, car length, car weight, horsepower, everything is there. And drive wheel underscore FWD. It means that whenever it will be a forward wheel drive, it will be 1, otherwise it will be 0. Similarly, drive wheel underscore RWD, it means that whenever it will be a rear wheel drive, it will be 1, otherwise it will be 0. Okay. Now, in the next part, what we are doing is, I'm adding a...
So if we have multiple categorical variables, we should always convert them into numerical like this for all of the categorical variables.
Right. Very nice. That's correct. Okay. And the code, the way that I have written the code, it is a very generic code. What do I mean by generic code? Just 1 minute. Like here, although it is selecting only one variable, but the way that I have written the code, even if there are 3 categorical column, 5 categorical column, 500 categorical column, this line of code will work. Because I'm not filtering the column by name. I am filtering the column by category. That should be of object category. It should be a categorical variable. In this one, it was only one variable, right? So whenever we are writing the code, always try to make sure that you are not hard coding your code. Don't call the columns by name as much as possible. Obviously, at a few places will not be possible, right? But as much as possible, make sure that you are not calling the variables by name. Okay. Even here, if you look at it, I'm not calling the variable by name. So all the categorical variables will get converted to dummy variable. In this case also, I'm not calling the variable by name. All the categorical variables will get dropped and their dummies will get added by default. Okay. In the next part, I am adding a constant. I'm adding a constant. Why? Because so that I can get the value of beta 0. Right? The way that we have discussed last time. Constant 1, 1, 1, 1, 1 everywhere. Again, next code is a very standard code. I'm splitting the data into test and train. Right? Train size being 80%, test size being 20%. Okay. What is the meaning of random state equal to 100 here? What is a random state means here? Any guess?
Randomly selecting data set.
Right. But why I need to add this? Like, what if I'll remove this? What will happen then? Will it not work?
It will work, but it will take in order wise, whatever in the data. It will take the first 80%.
No, it's not like that. Actually, what happens is that even if I'll remove this, it will randomly divide the data set into 80% and 20%. But the problem will be that every time I will run this code, it will select a different set of rows in train, a different set of rows in test. So this time it will be different. This time it will be different. Every time I will run it, it will be different. But when I set the random state equal to 100, it means that whatever the random split that you are doing for me, right? Even if I'm running this same code tomorrow, I should get the same train, same test. Same rows should go into train, same rows should go into test. Even if you're running this code in your machine, I have shared this code with you guys as well. Even there, whatever the rows that I am getting in training, you will also get the same rows in training, right? Although it is a random split, but still your answer and my answer will exactly be the same.
So how it is selected?
You can take any value, like it doesn't matter. You can keep it 99, you can keep it 1000, you can keep it your lucky number 7, doesn't matter. Okay, it's just that as long as it is same for you and me, we will get the same value for training and test. Same rows will get assigned to train and same rows will get assigned to test. Doesn't matter how many time I'm running it, doesn't matter where I'm running it, doesn't matter on which laptop I'm running it, nothing matters. Same test and train I will get. Okay.
So
So last time we have
in the place of 100.
Sorry.
Can take any value in the place of 100.
Any value. It's just that you need to keep that value like always. Like you can keep it as 42, right? 42 you can keep it. You can keep it 33. You can keep it 9. Does not matter. It's a random number. Any number you can put.
Puneet,
And there's a sorry.
yeah. You want me to continue?
Yeah, please.
Yeah, like in real-time scenario, it would be good if the data differs, right? Rather than keeping random state, I want data to be different and the model should be trained appropriately. That would be
Right,
the
right,
real-time
right.
scenario, right?
Right. No, actually, we don't want that. The reason being is, see, in a model, first I want to tune my model. I want to see whether everything, like I will show you later, that this is not the only thing which will be changing. I will be doing a lot of iteration, right? When I'm doing a lot of iteration, I want to keep something as a constant, right? If everything is changing, how will I optimize things, right? So we fix something, right? So here I'm fixing train and test first, right? And then I'm trying to optimize other things.
Yeah, I got this point. What I'm asking is like in real-time scenario, if I want to test my model, it would be better if I don't fix my test data and train data so that it will be better trained, right? At this point, I agree with you. You're fixing something so that you will get better accuracy. But once after getting accuracy, your model should not be fixed to certain test data and train data, right?
Yes and no, both. The thing is that yes, once I will get accuracy, what I can do is I can change this random split a few times and see whether the accuracy is consistent or not. Okay.
Okay.
If the accuracy is consistent, then again I will keep. I like to fix this split. The reason being is so that the results are replicable. When I'm creating my PowerPoint, right? You will be putting some number there. You will not be saying that my accuracy is somewhere between 89% to 92%, right? You will be giving some number that, okay, this is what 90% is, this is what my coefficient is, this is what my test accuracy is. If you will not keep the random state, that number will always keep on changing. Although it will not change drastically,
Yeah.
right? But will keep on changing. To create the PowerPoint, I want my numbers to be fixed, right?
Oh.
So yes, once I have tuned the model, if you want to verify whether by changing the data also I'm getting more or less same accuracy or not, then yes, you can try out 2-3 values of random state. But again, then finally I want to fix it before I start working on my PowerPoint.
Okay.
Okay. And for that, there is something called, there is a function actually, you need not to do it yourself. There is a function called cross validation, CV. Okay. So that function exactly does the same thing. It will, you can define the number of values. Let's say CV equal to 10, CV equal to 100. Or like what it makes sure is that when you say CV equal to 10, it means that it will be randomly splitting the data into test and train 10 times, then calculating the accuracy and will give you average accuracy.
Okay.
Okay.
Good.
So instead of me doing it manually, I can do it using a function.
Okay.
Okay. So here we have done test and train split. When I'm running it, I'm pretty sure that you will also get the same data. Then I'm checking train shape and test shape. It means that I want to see that, okay, how many rows are there in train, how many rows are there in test, and more importantly, how many columns are there. It should not have that the train has 8 column and test has less than 9 column or test has 7 column. That should not happen, right? It should have same number of variables. Then I'm checking Y train and Y test. make sure that whatever the number of rows that I have in X train, that should match with Y train. Whatever the number of rows that I have in X test, that should match with Y test. Why I'm doing this? Because again, the number of questions should match with the number of answers. Okay. So last part is nothing but one line of code. See, one single line of code for linear regression. I am giving X train as well, that is my question paper, Y train as well, that is my answers. So while training the model, I will be giving questions as well, I will be giving answer as well. Only then a model can learn. I need to tell my model that, okay, 2 plus 2 is 4, 3 plus 9 is 12. I need to tell the question, I need to tell the answer both for my model to fit. Once the model is fit, then I can ask him questions. Okay, but before that, I will be checking the summary of the model. Right? This time R square value is 80%. Do you remember what was the R square value last time?
66.
66%. Okay, let me open the previous code as well so that I can compare side by side. Okay, last time it is 66%, this time it is 80%, right? So has the model become better or worse?
Better.
Better, right? Because earlier I was able to explain 66% variability in the data. Now I am being able to explain 80% variability in the data, right? So the model has become better. I will also check the accuracy value, RMSE value later, but just giving you a high level idea. Other thing that I'm checking is the p-value. Okay, what was the use of p-value? How we use p-value here? What do we do? If p-value is greater than 5%, then what do we do?
We accept
the null hypothesis.
We accept the null hypothesis. What was the null hypothesis in this case?
Drop the variable.
Coefficient.
Coefficient is 0.
Coefficient is 0, right? Here the null hypothesis is true because p-value is greater than 5%. What was my null hypothesis? That the coefficient is 0. This particular value, can it be 0 if I will repeat it multiple times? If I'll repeat this experiment multiple times, if I'll create this model multiple times, can this value come 0? The answer is yes.
No.
There is a chance.
Oh.
Okay, we just look at the standard error. So what we are saying is the value is 76, but the error itself is 148. So 176 minus 48, 176 plus 48. So there's a big range. Okay, so main thing is we need to look at the p-value. If p-value is greater than 5%, we need to drop that particular variable. Okay, so what I will do is I will go back. Okay, I'll keep this commented. But this time what I will do is I will remove car height. Car height variable I don't want. Okay, and then I will rerun everything as it is. Okay, car height variable I have dropped. Do you see any change in the R square value?
It is reduced.
It is reduced very slightly, right? Last time it was some 808, I believe. Right? So more or less same R square value. So R square value has not changed much. Now let's see. So what we had removed car height, I believe. Right? Now let's look at which value is greater than 5%. This one?
Car length.
Car length.
Like here the standard errors are many, right? Like which one you are considering?
This standard error is this for car length. In this row, right? This is the row for car length. Okay, but we are mainly focusing on the p-value. If p-value is greater than 5%, then we need to drop it.
Like,
okay.
What's the reason for this?
Because
Can you please explain?
right. Because p-value tells me that whether this particular variable is important or not. Okay. Our null hypothesis in this case is whether my coefficient is 0 or not. Okay. When the p-value is greater than alpha, that is 5%, it means my null hypothesis is true. What is my null hypothesis? That the coefficient is equal to 0. So I'm saying that this value, if you will repeat the experiment multiple times, this value will come 0.
Okay, okay.
Okay. If you will repeat the experiment multiple times without even repeating it, I'm telling you that if I will repeat, then this value on an average will come close to 0. Okay. Now there is another variable which is where the value is more than 5%, but I'm not removing it. Why? Because this variable comes in pair with this variable. Okay. Either I would have to remove both because these are same variables, right? Drive wheel, drive wheel. So either I would have to remove both or I would have to keep both because one variable is less than 5%, other variable is greater than 5%. So one half of it is telling me to keep the variable, one half is telling me to remove the variable. So I will keep the variable as of now. But this one is one single variable car length. So I can remove it. I will go back. Look at the R-square value also, 806. Car length I need to remove, right? Yeah, car length. So we'll remove car length.
So does that mean that we have removed car height, and that made car length as invaluable?
Yeah, we do it one by one because these values keep on changing. Okay, so
Okay.
yes. So we have removed, so far we have removed two variables, car height and car length. And again, I will rerun this. Okay, last time, see the R-square value, what? 806. This is 804. Very minimal change in the R-square value, right? Now let's look at the p-values. All the p-values are greater than 5% except this one. But as I said, right, if you will remove this, you would have to remove the other variable also. They come in pair because it's the same variable split into two. So this is what my final set of variables are. Okay, I will be keeping car width, I will be keeping car weight, I will be keeping horsepower, I will be keeping drive wheel. Okay, now keeping this model as constant, now let's see what is our accuracy. Right, my accuracy is 3398. Okay, sorry, error. My RMSE value is 3398. How I have done it? Using my model, I have predicted on this set of questions. This is the same questions on which the model was trained. But this time I'm giving only the questions, not the answers. Okay, using my model, I'm predicting on the questions on which the model was trained. And the model gave me an error of 3398. What was the last time error? Last time the error was 4469 for train. This time it is 3398. So have we improved the model or not?
Yes.
Yes.
We have improved the model. We have reduced the error from 4400 to 3400.
But this is on the training part, right? We
Yes,
need to
right.
check
This
for
is on
the
the
testing
training.
part.
Very nice. Right. So we'll check that part. What I'm doing here. Okay. For some reason, I'm calculating it here, but let's see. So the test value is 4700. What it was earlier, the error 5500. Okay. So on test, I'm getting 5500 as an error last time. This time I'm getting it as 4700. So here also I'm saving the improvement. So overall, the model has improved.
So one question,
Yeah.
like, we have removed two columns, one
Right.
is car height and what was the other, car weight, right?
Right.
Yeah. So like if in real time scenario, if you see, okay, the price of the car having 4.3 meters and then compared to the price of the car having around, say, like less than 4 meters. So there'll be a price difference, right?
Right.
Yeah. So here, we have not included the car car length, I
Right,
believe,
right.
right?
So what it is saying is that like first of all, it matters that whether you are predicting the price without text or with text. Okay. So I am assuming here you are assuming without text. Okay. It's just that whatever the company is trying to sell it for. That is first part. Because when you will start including text, then there will be a like text is a fixed rate that you can add on each car, right? If I'm planning to sell a card at 5 lakh rupees, I know that how much percentage tax I need to put on that on top of it is a fixed thing, right? So when I'm trying to predict the price of the car, I will not try to predict taxes. I know that will be just 18%. Similarly, when I know that for the length of the car is more than 4 meter, then I would have to put let's say 25% tax instead of 18%. Right? So that
Okay.
number will change. As of now, let's forget about the taxes for now. Okay, if you'll forget about the taxes, what we are doing is we are saying that whatever the car, here, whatever the car length was trying to give me, the same thing can be covered using car width and car weight. Okay, so what they are assuming is as the length of the car will increase, the width of the car and weight of the car will also increase. And that combination, the width and the weight combination, will give me approximately how lengthy the car is. Okay.
I mean, still not able to accept it. The reason being, the car width of the smaller cars also may be high, and its weight can also be high. Like for example, if you compare Suzuki versus Tata.
No, Sumit, you are right that like this is not covering, I would say, each and every scenario, right?
Okay.
What we are trying to cover is a generic scenario, right? So it can happen that in some cases a short car might have high weight. That can happen, but will that if that will be a generic trend, it will be covered by our model.
Okay.
Okay, it's more of a like, let's say for example, the height of male and female. Not all male are what should I say? Not all. I forgot the word for it. The height of all the males will not be more as compared to female. There can be cases where, let's say, between like if you randomly select a male and a female, that doesn't mean that male will always be have more height as compared to a female, right? There can be a certain scenarios where the female height will be more as compared to male.
Okay.
Right? But a generic trend will be what? That in general, males are taller as compared to female. Okay.
So our model should be like, more generic, not
Yes.
the specific.
Right, exactly. Now, a lot of front wheel drive cars can be there, which are more pricey as compared to rear wheel drive, right? Or let's say there can be a front wheel drive, which is more expensive as compared to four wheel drive, right? But that is not a generic trend.
Okay.
Any other question, anyone?
How can I see the equation of this model?
Equation of this model will be nothing but your 4653 minus 4653 plus 583 multiplied by car width plus 4.7 multiplied by car weight plus 73.9 multiplied by horsepower plus 731 multiplied by whether the drive wheel is front wheel drive or not plus 3134 multiplied by whether the drive wheel is rear wheel drive or not. Okay.
Like in the previous code, we have all the variables, right?
Yes.
Oh.
In the first iteration, we had all the variables. Then with each iteration, we removed like a few variables, and finally we have these 4-5 variables. Okay, let's just for the
Here, where
our
you compared
understanding.
just one dot, like you said in the VIF, we need to remove the values which are less than or greater than 2.5, right? Like where you applied that?
Greater than 2.5, yes.
Yeah, where you
I
applied
have
that?
not applied it here. Like we can do it. Right. We will apply after this. So I'm saying that right now, just based on the model, I'm being able to do this much. Let's say, okay, let me go back to this. Here is that part of the code. Yeah, here. Okay. Let's see if I have kept all the variables as it is. Okay. I'm not removing any variable. Let's see what will be our accuracy. Right. Last time it was 4717 without updating the last one. It is 4690. Right. So if I'm keeping those two variables, right, my accuracy will improve because my error is going down between this and this. But do you see a like huge difference between these two errors? Are
No.
these two like very significantly different? Answer is no. Right. So even after I'm removing the two variables, my error is only increasing from 4690 to 4717 very minutely. And my model is becoming much more simpler. Like this is the more the number of variables, more complex the model is. I'm being able to remove two variables and error is increasing very slightly. Right. So by using p-value to remove the variables, that has helped us.
Our aim is to remove the variables which are not required.
Yes, exactly. Because that makes our model a little bit more easy, like simple.
And we removing variables by hypothesis theorem, right? By checking the probability and null hypothesis.
Right. We are removing the variable by checking the p-value. If the p-value is greater than 5%, then I'm removing that variable. Okay. And we also checked that after removing those variables, it is not changing our accuracy by a lot.
So if the accuracy is not changing a lot, then we can reinstate those two
Remove that
variables.
Yeah, we
Remove
can remove
or
that too.
we need not, even if it's like very minute difference in accuracy, we still can remove the variables.
Right. Yes.
Yeah, I mean, like we need not reinstate again just to make it more complex.
Sorry, can you repeat the last part?
Yeah, so even if the accuracy is like not changing much, even after removing those two variables, we can still remove those variables, right? We need not reinstate again to that point.
Yeah, right. This is what we are exactly doing. Once we have removed the variables and we saw that okay, the accuracy is not changing much, we will keep them removed only. We will not add them back.
Okay.
In real time scenario, do you ever use this simple linear regression, or you never use?
No, we use simple linear regression. It's a very popular machine learning technique.
But if there are more number of variables, it would be difficult, right? To check on everything, the relation.
Right. Right. So this is for everything. What we can do is we can automate it a little bit. Like 4 loops are for that only, right? Everything you can automate,
Okay.
right? You can create loop and you can remove it.
Mhm.
And we are just starting with it. There are other hell lot of things that we will be discussing, right?
Oh.
As of now, you might see a few gaps in the understanding, and I agree. Those questions will be there. But what I'm trying to do is that this is just the first machine learning code that we are running, right? So I'm trying to keep it as simple. For example, here I didn't discuss about a missing value treatment or outlier treatment or anything like that, right?
Yeah.
But yes, so with each machine learning code that we will run, I always try to kind of include a new concept in that instead of, let's say, including everything at once. Okay, because we want to also keep a focus on linear regression here, right? So with each one, let's say, for example, here we talked about correlation, this creating this correlation metric. Okay, so next time I will add a few more things. Next time I will add a few more things. So by the end of this course, you will know like everything more or less what needs to be done. Okay, done, guys. Any other question?
So every time we'll be using VIF also, right?
Yes, we should ideally use VIF as well, but again, only use VIF when there is a problem. What was the problem that we were trying to use? Solve using VIF?
The coefficient.
If the coefficients become inaccurate, then due to related variables, then the top related variable we remove it.
Right. See, VIF we use mainly when you think that I am not only concerned about the accuracy, right? I want to understand the relationship between the target variable and input variable, right? If my only concern is the accuracy, then VIF is not needed. Because does VIF improve your accuracy? No, right? Is that correct? It's clear to everyone that VIF will not going to increase your accuracy. Okay, using VIF, the accuracy will more or less remain the same. Okay, the accuracy of the coefficients will go up. We will become more confident on the coefficient value. Stevie, you have asked whether you said that using the same data, two data scientists might produce two different models because of different consideration in removing variables based on p-value. But why do you think that will happen? That why two data scientists will remove different variables, right? Because I believe both the data scientists will get almost the same p-value, and that's why they will remove the same variables only, right? Like right now, you and me, if we both are running this code, we will both get the same p-value for those variables, and we will both remove the same variables only. So whether you are running it or I'm running it, we will both get the same final model. When they choose to remove or not remove a variable based on p-value. If the p-value is greater than 5%, then we remove the variable. If the p-value is less than 5%, we do not remove the variable. Okay, and your p-value and my p-value will be more or less same.
Puneet, I have a question here.
Mm-hmm.
Like, if all data scientists are following the same path, then what's the point? We can automate it, right?
Actually, very nice, right? That is actually the case. So what happens is that in general, people assume that running a machine learning model is what makes a data scientist, okay? Which is not true. Running the machine learning model is never be your main task. Anyone can run a machine learning model. You are right that if the same code will be run by you versus it will be run by me, I have 10 years of experience. You don't have experience in this field, but we'll both get the same result. Okay. So what's the point of having experience? The idea is that before we put a data into the ML algorithm, a lot goes behind that, right? Here, I have just given you the input variable and target variable. And using that input variable and target variable, you are running a machine learning algorithm. Okay, and we are getting the result. But which variable should have been created, from where I will be getting those variables, right? Then which machine learning technique to use, whether linear regression will be a good fit here, or XGBoost will be a good fit here, or random forest will be a good fit here, right?
Yeah,
So
at that point I got it. But like if we choose linear regression, then the path that should be followed is same. Like it depends on discretion of the engineer who decides which model to do and which variables to delete or something. It's up to
right,
discretion of ML engineer. But my
right.
question is, if suppose they arrived at conclusion that they both should use logistic regression or something, so the approach would be same and approach would be more or less same, or I feel
Yes,
I
more
feel
or less.
like this independent variable may not be useful. That was
No,
actually
In like the subjective calls that in general we take, the subjective calls are in general to reduce the runtime, right? Technically, ideally, we both should use the same path,
okay.
right? That we should first do the missing value treatment, we should do the outlier treatment, then we should do a train test split, then like before that we should do dummy variable creation, then we should do a train test split, then I should run the model, see where the p-value is greater than 5%. Wherever I'm getting more than 5%, I will remove that variable, rerun it, again check where I'm getting more than 5%. If there is a variable more than 5%, remove it, again run it, right? Do it till you will find no variable where the p-value was more than 5%, right? That is your final model. Check what the accuracy you are getting and done, right? We both will follow the same path. But
Okay.
a few subjective calls sometimes we take when, let's say, the things are not running. I run the iteration that is running for the last 4 hours, 5 hours, nothing is happening. Then I might have to tweak here and there. That I might have to take a decision before even running the model that, okay, this variable might not be useful, right? So how will I take that call? Sometimes that call comes from the business knowledge. Sometimes
Yeah.
that comes from a few other tests we can do based on, let's say, what is the correlation value, based on a few other tests. We see that, okay, whether this variable may come useful or not, or maybe we will check the VIF first, right? All those things we do, right? But those are the things to make sure that the runtime is less. So that is not the most technically correct way of doing it, but that is more practical way of doing it.
Okay, so more or less it will be same for two people doing it, but more like depends on the experience or the business knowledge. You will be
Right.
able to decide which are good and which
Which
can,
are
yeah.
right, exactly. And on top of that, one big thing that I think we have just assumed, which will be same, you assume that you and I will start with the same data set, okay? Which I believe is the wrong assumption. Based on the experience I have seen, the people who are more experienced in general start with a better data set, okay, in terms of getting more number of variables, from here and there, this and that, right? Making the right approximations. So based on your experience in that field, based on your experience as a data scientist, a more experienced data scientist in general starts with a better data set as compared to the other person, which in your case we have assumed to be same,
Okay.
right?
So what do you mean by a better data set?
Let's say using the right set of variables, like as I was telling you, it's not about having more number of variables, more about having more number of relevant variables, right? uh, just knowing like gender will be a relevant variable to predict height, parents height will be a relevant variable to predict height, but what other variables I should include, right? Should I include the diet of the person? Yes, diet will also have an impact on the height of a person, but do you think getting the diet of the person is a very straightforward variable to get, right? What kind of diet you have taken in your life versus what I have taken in my life, how are you going to simulate that variable, right? How are you going to approximate that? Maybe that is something, for example, like these questions sounds very easy, but in general, it requires a lot of business knowledge. It's not very easy to think of a variable which will be similar to the diet that the person has in his life, right? So this is what I meant when I said a better data set, because more the number of relevant variables that you can think of, at the same time that you can create also. Diet is a very important variable that I can think of. Diet is an important variable to predict someone's height, right? But how to create that variable will be a problem. Okay, so in general, as a data scientist, we spend more time thinking about the variables, right, than actually doing the machine learning part, because we know that once you have a good data set with all the relevant variables and the target variable, then our job is done, right? In general, after that point, all I have to do is run an automated script and I will get the answer.
Oh,
But in the case where you mentioned about the diet variable, so so to get the data set for specific to diet variable, so is it something that we have to collect as a data scientist? We have to collect it ourselves once we work on the task, or is it like we will already get a data set including the diet variable as?
No, actually, many times we have to create it, right? So how the process is, in generally, first think of all the variables which can be used, right? Then you go to the data engineering team and you tell them that these are the variables that I'm looking for. These are 10 variables I want. They will say that, okay, out of these 10, these 7 are available, 3 are not available, go back, right? Now it is your choice. You will come back to your test and use only 7 variables. Or maybe you will think that, okay, these 3 variables are not available. What can be the alternative of this? Right? Let's say, for example, if car weight is not available, but car length is available, right? So I know that car length and car weight will be correlated with each other. So even if I'm not getting car weight, let's get car length. I'm giving a very crude example, right? But I'm just saying that sometimes we have to think in that way that, okay, if this is not available, what else is available which can give me the similar thing, right? Let's say, for example, about the diet of a person, right? I want to see that who will live longer. Let's say there is a person A, person B, and I'm working in the insurance industry. And I want to check who will live longer, who will have a healthier life, because more healthier the person is, lesser chances that he will get sick. So lesser the premium I would have to give to that person, right? But whether someone will live healthy or not, that depends a lot on the diet of that person. But that variable is not available, right? But what if I have a credit card data available, right? Credit card data available, if I have, I can see that how much you spend on eating outside. Like I can simulate like how much money Vishal is spending per month in a restaurant versus how much money Puneet is spending on the restaurant. Or let's say I can see how many times Vishal has spent money on, let's say, alcohol, like because there is a separate MCC for alcohol, and how many times Puneet has spent money on the alcohol part, right? So from there, I can simulate that who is having a healthier lifestyle between Vishal and Puneet. Like, will it be 100% accurate? No. It can happen that maybe I'm also drinking a lot, but my friend is paying for it, right? Or maybe you are spending a lot on alcohol, but you are not drinking at all. You are just throwing party and your friends are drinking it. Right? But it can it will give me an approximate picture, because in general, the person who will be spending from alcohol, most of the time he will also be drinking, right?
Yeah.
Yeah. So we have to think of those variables. That, okay, if this is not available, what is available? Can I make a proxy of it? Like, will it be accurate or not? In that way.
Got it. Thanks.
Okay. Any other question, anyone?
This feature selection can also be mechanical, right? Like if you follow everything correctly, and say maybe this example I'm taking, and so we can have a, like, say we'll use VIF and we'll get the actual exact, like which feature is actually important, and then we can use that feature only first, and or and then this like when you run this like when you and then say categorical variable you changes to numerical, and then you run this model, train this model, and you get the model, and from there you can get you are always getting this um, p value, and these all can be mechanical, right? Like then I was saying that data scientists, it will I know with business, who have the better business knowledge, he could get, but I see like if you follow everything, what exactly should be done, can this be mechanical, right? Like it will finally it will give you a exact what is required for the.
Right. You are actually right. And I'm telling you that, like the first company that I worked for, they actually had that tool, something that they had developed in-house. What we need to do is, in an Excel, we need to give them like certain parameters. Let's say, for example, which one is my input variable, which one is my target variable. In the Excel itself, I need to mention which variable should be categorical, which variable should be numeric. Okay. What the automated code will do is it will check for each variable. Let's say I have said car ID should be categorical. So it will check that, okay, whether car ID is categorical or continuous. If it is categorical, it will keep it as it is. But if it is, continuous, right? And I have mentioned that it should be categorical, so it will change the data type. Okay. Then it will check whether any missing values are there or not. Even for missing value, I can just simply write a code to check if the missing value is less than 2%, remove the rows. If the missing value is less than 20%, impute the rows. If the missing value is greater than 20%, remove the column. Okay, again, very automated. Then I can go to the next part and I can say that, okay, take all the categorical variables and convert them into dummy variable and drop the first variable. Again, very automated, right? I will go to the next part and I will say that, okay, split the data set into test and train, very automated. So everything can be automated, right? You are right. It's not that big of a deal. Okay, it's not that big of a deal to run a machine learning model. It's easy. Okay.
So in some days, the role of in few years, the role of the data scientist also will become obsolete. Like how it will evolve over the years.
See,
instead of getting down.
Right. See, everything evolves. It's just that our role changes a little bit. I remember when I started doing this, right? Everything we used, like R was a little different as compared to Python. It was not that easy. In R, whatever we are doing in Python in 2 lines of code, in R it used to take 10 lines of code. Okay. When Python came, the things became easier. Okay. So now I can do more number of things in the same time. Now when deep learning, AI, everything is coming, let's say now these days we know that, like let's say for example, if I'll add a column here, it can ask me to generate with that, like code for VIF. Okay, so where is the code? That is there, but where is the code?
It generated down.
Oh yeah, right here. Yeah. So for example, it has given me the code. Earlier, what it used to happen, I would have to write all this code on my own. Right. So think slowly and slowly will get automated, but your role will change a little bit, right? There will always be a person sitting on top of it to check whether things are running like smoothly or not. Earlier, people used to make one model in 3 months. Then they started making one model in 1 month. Then they started making one model in 1 week. Okay. But again, there will be people who will be doing all of this. It's just that you will become more efficient.
Okay.
Okay.
Puneet, I have one question regarding that insurance premium. Suppose if I have data and in that data, I have an variable which is healthy lifestyle. So
Right.
I have answers for, I have data for it. However, I prefer to get the data validated by checking the credit card information.
Okay.
So for example, there are 100 columns and out of which this credit card and healthy lifestyle, 90 matched and 10 mismatched.
Okay.
So I assume that credit card information is more reliable. So
Okay.
I wish to replace those 10 columns in the healthy lifestyle column to this newly generated. So
Okay.
in real-time scenario, can we just manipulate the data based on our indirect variables?
No, it's not manipulation. It is you using your mind, right? So this is definitely not manipulation as long as you're calling it out. Okay. So whenever we make the presentation, we try to add as much details as possible. Like we add this much as well, that okay, I started with 500 variables. Out of those 500 variables, I had to remove these 70 variables because the value was present only in like the missing value was more than 20% of the time. So I had to remove these 70 variables. Then maybe these 20 variables I had to remove because the value was same everywhere. Let's say if there is a column where every value is just male,
Yeah, got it.
right? Then that variable is useless, right? So I will remove. So when we create a PPT, we add each and every detail that, okay, this is how we started and this is where we, this is how my final data set was looking like. Then we said that, okay, out of this much was categorical variable, this much was continuous variable. And there are few variables that we have generated on our own, right? Inferred variables.
Yeah, my question is like I'm taking the real data and I'm taking the assumed data. Credit card is something like I used my mind, I calculated. This is the data
No.
I'm thinking
This is not assumed data.
Okay.
It is additional data that you have taken. Okay. Assumed would have been that you were sitting and saying that, okay, for Puneet, the value is 0. For Abhinav, the value is 3. For Neha, the value is 7, right? That would have been the assumed data and that will be wrong. Right? But what you are doing is you are taking an additional data. You are taking the credit card data and using that credit card data, you are trying to create a few more features which are important for your target variable. Right? That is additional data. That is not assumed data. That is not data manipulation.
So no, I'm taking the additional data and I'm changing the original data. You got my point. These 10 columns I'm trying to replace.
There is no need to replace it as such. You can just add them additionally, right? Why to replace them?
Okay.
See, with machine learning, the best part is even if you will throw unnecessary columns to it, my machine learning model will be able to identify on its own, right, that this variable is important, this variable is not important.
Yeah,
If I'm
okay, then I'll drop the previous data and I'll use this credit card. So that works, right?
Yes.
Okay. Thank you.
Any other column, guys? Oh, sorry, any other problem, not column.
I mean, most of the time we spent on data preparation, data cleaning, data processing only then.
Right. A lot many times even to identify the target. Like target sounds very easy, right? But it is not that easy to come up with. A lot of bandwidth goes into deciding the target. The targets are in general not very easy, like predict the height, predict this, predict that, right? A lot many times, like for example, when we say a bad customer from a bank perspective, right? It sounds very easy, bad customer, right? Someone who will not pay me. But how you will define it technically? What do you mean by will not pay me? Will not pay me by how much, right? Not every customer is bad customer for all the loans. Maybe I'm a good customer for 50 lakh rupees loan, but I'm a bad customer for 5 crore loans, right? So there is no 0 and 1 for me. Maybe there is a range for me that till this particular loan, I'm good, right? So when we start thinking of a target variable, we realize that it is not always very straightforward. Okay, so even that takes a lot of time. We need to have the right definition of target variable. We need to have right input variables. From there onwards, the things become very easy.
Okay.
Okay, if there is no question, then that's all for today. The linear regression. Yeah.
One question. Can you explain on any project that you work with, like what you have taken like input and what is the target?
Okay, let me just think of something. Okay, it reminds me of this project I worked on related to churn analysis. Okay, so churn is in general considered in any industry, like the churn definition can be used for any industry where there is a recurring transactions happen. For example, in case of your telecom, right? I'm assuming that if you have a connection, you must be paying for it like every month, like the Airtel bill that you will be paying every month. Similarly, if you have a subscription, let's say Netflix, you must be paying it for every month. So wherever you on after some time, whenever let's say you regularly transact with someone and you stop transacting with that particular company, that is called churn. Okay. So let's say if I was using Airtel and then I stopped using Airtel altogether, then it will be that I have churned out of Airtel. If I was using Netflix subscription, then I stopped paying for Netflix subscription, I have churned out of it. Similarly, let's say if I'm working for a mart, like for example, Walmart or let's say Target, right? There the people also transact regularly, like or let's say Amazon, Flipkart. Now, there will be few people who will be one and done. One and done means that you will come, you will make one transaction, you will never come back. Okay. And then there are certain customers who are very regular to you. Like for example, in case of Walmart, there will be people who will be coming almost every month, and then they will be making purchases. Like the ration they will be filling, and then they will not come again for 1 month, and then again they will come next month, right? So for all the companies, most of the revenue come from regular customers, right? If you will look at the Airtel revenue, split, maybe 5%, 6% is coming from the new customer. The remaining 95% is coming from the existing customers, right? So I want to see how many customers are getting churned. That is one thing. That okay, if previous month I had 100 customers, whether this month I have, let's say, all the 100 customers came back or not. But there can be multiple reasons because of which the customer might not come back. I purchase ration, let's say, from Big Bazaar. Okay. Does that mean that every month I will be purchasing ration only from Big Bazaar? No, right? A lot many times, maybe I'm traveling, so I'm not purchasing. It can be the case that my family is out of town, so the previous month ration is already there. So I'm not going to Big Bazaar for because of that reason. So because of them, there can be multiple reasons because of which the people might not come next month, right? But after how many months you will decide that okay, if he is not coming after these many months, then the customer is not going to come back. How will this is a question to everyone. Let's say you want to decide number of days that okay, if someone is not coming after these many days, I will consider that the customer is churned. How will you decide that cutoff? You understood what the question
Yeah.
is?
Maybe 3 months.
Maximum it could be 1 year.
1 year, okay. Someone said 3 months. Someone might say 6 months. Someone might say 5 months. But the problem is that this is what I was telling you, right? When we think about something versus when we have to write down something, those two are very different things. When we are thinking about it, we can say that, okay, 3 months or 6 months or 1 year, right? But when you will be writing it down, the person is going to question you why you have decided 3 months, why you have decided 6 months, why you decided one. So there should be logic for everything. Now you are supposed to think of a logic. Again, this is not a machine learning problem. This is a simple math or common sense problem, right? That you need to decide or think of a cutoff, that this is the cutoff that I will be taking, that if the person will not come by then, I will assume that he is churned. Can you think of something?
By taking any reference data.
Can you explain a little more?
Like if you have any previous data.
No, we will have previous data, right? But how you will use previous data? That's the main part. We have previous data.
Like we need to check like when the customer is stopped using our ration or not, and how much time he took long back to come back
Mm-hmm.
and purchase
Mm-hmm. Nice. Good.
that period.
Mm-hmm. Maybe what we can do is we
Generative
can
regression.
Average is there. Yes, nice. Or maybe what we can do is, I can make this graph and I can say days since last transaction. Days since last transaction. Okay. Let's say if I will take all the people who have not transacted in the last 10 days. Okay. All the people who have not transacted in the last 20 days. Similarly, 30 days, 40 days, 50 days, 60 days, 70, 80, 90, right? And so on. And on the y-axis, if I will plot percentage of customers who returned, right? Whether the customer returned or not to make the transaction. Like of all the people who had a gap of 10 days, out of all of these people, how many people came back? Okay. Let's say maybe 90% came back, because a lot of people will come back, right? 10 days is nothing. A lot of people like will come back. If I will look at if the 20 days have passed, how many people will come back? Maybe certain people will come back, certain might not come back. If I have 30 days, how many will come back? Some percentage will come back, some percentage will come back, right? And after a point, you will realize something like this. The probability of people coming back reduces significantly, let's say after 50 days, right? If a person is not coming back for 50 days, then the chances that he will come back and make another order, let's say it is 10%. Hypothetically, I'm just adding some number. If all the people who have not made any transaction in 50 days, in the last 50 days, only 10% of the people will come back and make a transaction. It means 90% customers will never come back. Okay, so here you can see that maybe 50, I can take it as the number of days after which the person has churned. Because if someone has not made a transaction for the last 50 days, the chances that he will come back and make a transaction is only 10%. 90% he has churned, right? So 50 days, I can keep it as churn, right? So that will be my target variable. Okay, now, if anyone is not making transaction the last 50 days, that's what I want to predict, that whether someone will churn or not. Now, there can be multiple reasons because of which a person might not make a transaction, right? One thing can be he had a bad experience with you. One thing can be that person has died. Third thing can be the person is transferred, right? Because let's say if I'm talking about Big Bazaar, currently I'm living in Bangalore. If I will move back to Delhi, right? So will I be transacting with same Big Bazaar? No, I'm not living there anymore, right? If I will have a bad experience with Big Bazaar, will I go back again? No, right? But from a company perspective, can you differentiate between these three? Let's say if there is a person who has stopped coming to you, how would you know that what out of these three has happened?
No, we can't decide on it.
We cannot decide, right? Like from a company perspective, if I knew about whether this has happened, this has happened, this has happened, can you do something in this case to bring back the customer?
Yes.
Yes. Can I do something in this case to bring back the customer?
No.
Yeah, we wish, but there's nothing we can do, right? Similarly, there's nothing we can do in this case also, right? So it means that even though there are certain percentage of customers that I have identified that are not coming back, but still only out of those customers also, only a certain percentage I can actually bring back. There is nothing I can do for the rest of the customers. All right. And I don't even know the split. Maybe this is 90% and this is 2% and this is 8%. Right? Or maybe this is 70%, this is 10%, this is 20%. How do I know? Right? So these are all the challenges that we have in predicting something. Okay, first of all, coming up with the target variable itself. The target variable itself was, I'm telling you, a very straightforward approach. There were like many other things as well here. Many other things. Right? Just to decide the target variable, we would have taken at least 2 weeks. We think it from a different perspective. We just don't make one graph. This is at an overall level. I want to look at the same graph from different customer tenure perspective as well. Maybe with new customer, if the customer is not coming back after 30 days, he will not come back. But maybe with the experienced customer, even after 60 days, he has a good chance of coming back. Like, how do you know? So will you treat both the scenarios equally? Answer is no. For new customer, if you're not coming back after 30 days, it is an alarm bell. Right? Because it's not going to come back. But for a tenured customer with the experienced customer, maybe 60 days is still fine. He will come back. Right? So again, I'm just giving you one example, and I'm telling you that if you'll start talking about it, there was a reason we took like 2 weeks just to decide the target variable definition. Okay, we need to look at from a different market perspective. We need to look at the different customer perspective, right? This graph can change by market also, right? Maybe the people in the Delhi are of different behavior as compared to the people who work in Bangalore. The people who work in Bangalore are of different nature as compared to the people who work in, your Mumbai. Just giving an example. In Delhi, most of the people are not migrant as such, right? Like they are from neighboring states only, like Punjab, Haryana, Uttar Pradesh, Rajasthan and all. But from Bangalore, the people are from like all over the states that they are from, they are far from Bangalore. Like Uttar Pradesh is far from Bangalore. Your Rajasthan is far from Bangalore, right? So there is a good chance that the people might want to go back to their home state. Right? So maybe there will be more percentage of people who will stop transacting with me because they got transferred. Transferred, I mean, like they found a job near to their hometown as compared to someone is working in Delhi. Lesser number of people will be moving out of Delhi. The reason being is that most of the people who are working in Delhi are from the neighboring states only. So if they are not working in Delhi, where else they will go? Right? But a person who is working in Bangalore and let's say he's from Uttar Pradesh, he might want to go back to Delhi because it is near to the hometown. So there will be more number of people who will get transferred from Bangalore as compared to the number of people who will get transferred from Delhi. So the market wise, it can change. Right? So yeah, let's stop this discussion here. But the point being is that the target variable can change drastically, and it requires a lot of research, data plotting, charts, thinking of all the scenarios to come up with what should be my target variable, how should I approach this problem. Okay, any question?
So one question, like, is it does that come under the role of data scientist to know
Yes.
how many people have transferred and
No. So
he may not be doing by himself, but can he take the help of others, to
No. Sometimes my job is to think of all the scenarios and come up with the numbers if I can, right? If my job was to think of all the scenarios, so I told them when I was actually working on this, I told them that there are 5-6 different scenarios because of which the people might stop transacting with you, right? So assuming that let's say out of 100, there are 40 people who have stopped transacting with you, right? And then you are expecting me to bring back all the 40 people. That is not possible. Why it is not possible? Out of these 40 people, a few must have died, a few must have transferred, a few must have had bad experience. The people who had bad experience, I can improve their experience, I can bring them back. But the people who are getting transferred, the people who are dying, irrespective of how many coupon you're gonna send those people, they are not gonna come back, right? So my job was to also put a realistic expectation there, right? That these 40, all the 40 people I cannot bring back. I can bring back only a certain percentage of it.
Okay.
Like here, apart from this technical knowledge, we need to get more general knowledge, right?
Yeah, right,
How
right.
the
Yeah.
scenario is going.
Right. But don't think like what we do is that as of now, you all must be thinking of yourself as an individual who will be working on a problem, right? Don't think it that way. It's always a team, right? It's actually a very nice discussion. We will be sitting in a room thinking of all the scenarios, like the people will come up with the ideas and all of that. It's not like that I'm sitting on my desk thinking of all the things on my own. Then maybe after 3 or 4 days, I need to give a presentation. It's not like that. It's always a team. It's very fun to work with all these ideas. You will have some ideas, other people will give you ideas, you will build on those ideas, all of that happens. So don't think that how will I think of all of these things. You will not be doing it alone. A lot of people are always with you who have experience, who have done something similar, right? They will help you out, and then we do it like as a team. Okay. Yes, TV. So you are right. A lot many times you might not align with the business team. Business team might have a different thought as compared to what you have. But at the end of the day, my job is to explain the business owner that why do I feel this is the right definition, or this is the right variable, or this is the right modeling technique that I should be using, right? But at the end of the day, it will always be call of the business owner or the sales team, which will be deciding that okay, what should be done. Like of all the scenarios which are there, which scenario I want they should be using, right? So we can give our presentation, we can give our thoughts, but yes, the final decision sometimes lies in the hand of someone else. Okay, which is fine. Our job is to kind of put the presentation in as simplistic way as possible to make them understand what is the right decision should be, right? But at the same time, they are also very experienced. So we should respect their opinion also, and at the same time, at last, their decision will be final. Cool. That's all, guys. That's all for today.
So one last question. One last question. Like
Mhm.
till now, we have discussed on the linear regression, right?
Right.
I
Yes.
mean, a linear equation, more of a kind like linear equation with multiple features. Like what if if we get non-linear features, inversely related, or after sometimes it increases and then decreases. So we can't solve those issues using linear regression algorithm, right? Like then what do we do?
We can actually. So let's say just 1 minute quickly. There are different ways to deal with it, right? You can do variable transformation. You can take a log of something, e raised to power something, 1 by something, right? So first of all, what we try is that if y is not linearly related with x, we try whether y is linearly related with 1 by x or not, whether it is related with log x or not, whether it is related with x square or not, x cube or not, and e raised to power x or not. These are the 5 variations you can always check.
Okay.
Okay. So in general, y is not linearly related with x. It will be linearly related with one of these.
Okay.
Okay.
Then we can
Even
use those standardization features like which we discussed last.
right. Or like there are other things as well that you can do. Let's say between y and x, the relationship is of this kind.
Yeah.
Right. In this case, sometimes we look at the chart and we say that we will create 2 variables. Okay. How these 2 variables will work? I will create y x1. It will be 1 everywhere. It will be 1 everywhere. And after this point, this point that we had, its value will become this. Okay. It's more of a like x1 does not matter when it is less than this. But after this point, its value starts mattering. right? Similarly, I can split it like x2. So it will increase, but after this point, it will become 1. Okay, so from same variable x, I have created two variable x1 and x2, right? See, if you look at it, when from here to here, variable x2 will be active, and from here to here, variable x1 will be active. So there are multiple ways are there. Like the machine learning is very big. Okay, a lot of things you can do. Okay, it's just that we are just starting with it. We have just learned one machine learning technique. There are a hell lot of different things which are coming.
Okay.
Okay. Yeah, that's all, guys. Thank you, and I will see you tomorrow. And tomorrow we will start with logistic regression. Okay, bye-bye.
Bye.
Thank you.
Thank you.
Thank you.
Bye.
Yep,
Thank you. Bye.